Okay, so today we are going to discuss chapter 8, that is differential equations, right? Okay, so yes, now you can see the screen, right?
Yes.
Okay, now Ranjani, what do you understand by the term differential equations? Any guess which you can make, anything?
Differentiation. It's basically
Yes,
differentiation, but
very good.
differentiating an equation.
Yes, exactly. Okay. So we have this word equations means we'll be having this sign. This word differential means differentiation. For example, it could be that we have dx by dt equals something, right? That something could be any function. Let's say we have x, for example. Okay, now in this chapter you will see that after reading some statements we will end up creating a differential equation, and how to solve the differential equation you already know that. Okay, so this chapter is not that new. The only different thing is that it is a mathematical application of differentiation. So far you have been differentiating so complicated functions, but this time you will see that differential equations basically is an application of differentiation. Okay, now this is very important thing, right? It is an application of differentiation. Like you know that the derivative of x with respect to x is 1, right? But why do we find these derivatives? And why is it important? And what is the significance of using all this? We will discuss that, okay? So all this content, you know this, but the making of differential equations in order to solve some mathematical problems, that is going to be a new thing, right? You will understand. Don't worry. Okay. So, okay. And we know that rate of change of x is written as dx by dt. Okay, so rate of change of x, this numerator is change of x and denominator is telling us that it is rate, right? You understand what rate is? It is change of
It is
it.
the
Sorry.
change of something with respect to time.
Exactly, right? So we are clear with this, the second point, right?
Yes.
Okay, and now we have the main statement. If there is a link between rate of change of x with something, because obviously in different situations we will have different things, we use differential equations. Okay, now the very first line is telling you it is an application of differentiation. Okay, then the second thing is telling you that rate of change of x is written as dx by dt, and the last point is the main thing. If there is a link between rate of change of x with something, we use differential equations. Okay, now obviously this link could be directly proportional or It could be inversely proportional. So far you only know that you'll be given a problem, you'll read that problem, and after understanding that problem, you will try solving it using differential equations. Okay, we'll talk about an example and then you'll get a better idea. Okay, so I will rub all this and let me just write down the example. This is the first example, and this chapter is very small, so we'll only be needing 1.5 classes for this. A culture of bacteria is modeled as growing at a rate that is proportional to its size. The population size of the culture at time t hours is b. Initially, b is 200 and after 10 hours it has become 400. All right. So the very first part is use this information to form a differential equation. Right. Okay. Now let's read the question first and let's understand it. Okay. A culture of bacteria is modeled as growing at a rate that is proportional to its size. Okay. The population size of the culture at time t hours is b, right? So basically, they are telling us the symbol which we will be using. Okay, they are denoting the size of the culture at time t hours as b. Initially, b is 200. Initially means when time is 0, and after 10 hours, it has become 400. Use this information to form a differential equation, right? So clearly the question is telling you that you need to use the given information to form a differential equation. Now it is not new. Okay, it is not new. You will use everything, all the old concepts here in order to solve this question. The only thing which I will write here is that this rate is basically what? D B by dt. Okay, why B? Because the population size
Yeah.
of the culture at time t hours is B, right? So B is the symbol which we will be using, and this is rate. Okay, and what is the statement? A culture of bacteria is modeled as growing at a rate dB by dt that is proportional to its size. The population size of the culture at time t hours is b. Okay, so we also have b here. That's it. You have been doing such questions, right? Where we use the
Have to,
proportionality sign, and
yeah.
when we remove it, we write down a constant. So nothing is new. You know that you
Okay.
have differential equations, so obviously we will be having such statements, and this basically is representing rate. Okay, so we can write it dB by dt equals kb. That's it. This is your differential equation. Yes, and in old concepts, like in those questions, in the proportionality questions, we used to find uh, this k as well, but we will do that not here, in the next part. Okay, so whenever you have been asked to form a differential equation, it would be of this type. So any questions so far?
No, it's fine.
Yes. And are you understanding it? Like, are you finding it easy or difficult?
It's fine.
Okay. All right. So we have this differential equation dB by dt equals kb. And the next part is show that b equals a e to the kt is the general solution, and find the particular solution. Okay. Now this is the second part, okay? And you are not familiar with what general solution is and what particular solution is, so I'll tell you. Whenever you have a differential equation, at the moment it is written as dB by dt equals something, okay? We are not sure about what b is going to be, right? And your end goal and end target is to solve the differential equation. And how do you solve a differential equation? We have been doing that. We have been integrating things, right? And we know that whenever we integrate this type of a thing with respect to x, we get x, right? So we know that
Yes.
through integration, we can easily find the x. And in these questions, the information would be given such that we are able to make the differential equation. But at the end, we have to solve the equation. Okay. So how are we going to solve that? We'll do that in the next part. So far they are not expecting that you know how to solve a differential equation, but they are just saying that show that this is the general solution. Okay, and what is the difference in general solution and particular solution? If this is the general solution, when you will find out the values of these constants, this would become particular solution, right? This is the only difference in
Yes.
general and particular. But now the question is that how do we do the first thing? How do we show that this is the general solution? Okay, as I just said, when you integrate dB by dt with respect to t, you will get p. Okay, and you don't know how to solve it, you just know how to differentiate it. Okay, so in order to show that this is the general solution, we will differentiate this expression with respect to t on both sides, and we will get this differential equation. Let's do that. So what do we have? We have b equals a e to the kt. They have given this, and we need to show that this is the general solution. And how are we going to do that? But basically, sorry, starting off from here and ending up here. Okay, right. So let's do it. For how can we get this type of an expression over here? By differentiating it with respect to t, right?
Yes.
So this would become dB by dt, And now we have to differentiate the right hand side. So what is the derivative of this side, Anjali?
Um, are you supposed to
Yes.
use the product rule or
No, no. A is a constant. A and K are constants, okay? A and K are constants.
RT e to the power RT?
Say this is K. This is K.
I mean, yeah,
Yeah, okay. So what are you saying?
KT e to the power KT.
E to the power KT, and what do I write before it?
KT.
No, not KT. Look, this is T. You are differentiating it with respect to T. The derivative of KT with respect
Oh,
to T
okay.
is,
So T is just like X, like
yes, yes,
oh,
yes, exactly,
okay.
exactly. Okay. And this A is going to come as it is, right?
Yes.
Okay. So can I just rewrite it as K A e to the kt? Why? Because what was my target? I have to start from here and end up here. Okay. The left side is okay, but this is not kb. We need to use this definition again, and using this definition we can write k b, because we have been told that b equals a e to the kt, right? So this red box is basically b. So now I'm clear. Now I have db by dt equals kb, and this is what I had to show, right?
Yes.
Okay. Sorry. Now this is the general solution. I repeat once again. In this question, they have given you the solution. So far, I have not told you how to find the solution. Okay. You just had to prove that this is the solution for this differential equation. And how do you solve such questions? By basically starting from here and ending up here. Okay. And obviously, for that, you need to differentiate both sides with respect to t. And after just using substitution, in this part, we got our differential equation. So is this clear?
Yes.
Okay, right. So we have showed that this is the general solution. But what is the next part? We need to find the particular solution. And
Particular
how
solution.
do we find particular solution? By finding out the values of constants which we have in general solution, right? Okay, so
Yes.
B is a e to the kt. What are the two constants? A and k. These are the two constants, right? Now, how do we find them? We need to use this data. Okay, so they are saying initially B is 200. Initially means at time equals 0, B is 200. And what is the next information? And after 10 hours, it has become 400. So at t equals 10, B is 400. Are you clear with this?
Yes.
Okay. Now we have to find A and K. In order to find K, I can use this. Okay. So I will have B equals 200 equals A e to the 0, because T is 0. So this implies that A is 200. And whenever you will have a solution of this type where you will have an exponential function, always remember you will use t equals 0 for finding out this constant, because only then your this factor would become 1, right?
Yes.
Okay. And otherwise it would be very complicated to solve an exponential equation. Although we can, but still this is advisable to use t equals 0 for finding out this constant. And the next constant is k. So we rewrite the equation using the value of a. 200 e to the kt, and now we can use these two. 400 equals 200 e to the 10k. Now I can take this to that side and I will get 200 equals e to the 10k. And what is the next step? Sorry, I will get 2. I will get 2, right? 400 divided by 200 is 2. Let's just do that. I'll divide by 200. This would become 1 and this would become 2, right? So we have to take natural log on both sides. Ln of 2
Yes.
equals ln of e to the 10k. This will come over here and ln e is 1. Ln 2 equals 10k. Ln e has become 1 and k is basically ln 2 by 10. So this implies that k would be 0.069. Finally, we have our k, we have our a. So we can write b equals 200 e to the 0.069 t. Okay. So are you clear with this?
Yes.
Okay. Now, whenever you have general solution, every time the solution would be with some constants. And in order to figure out the particular solution, we will find out the values of A and K. Okay, obviously the constant would vary from question to question. We are not going to have A and K every time, but this is how we have to work. Okay, the third part is describe any limitations of this solution. Okay. Now, what is the solution? Since we have to describe the limitations of the solution, let's write down the solution first. We have B equals A E to the K T, right? And they want us to, okay. Now, the very first thing is that what is this solution telling us? Whenever we will have a time, let's say for t equals 0, we were told that b it was 200. Okay, then for t equals 400, sorry, for t equals 10, b was 400, right? So on, for different values of t, we can find the size of our bacteria, right? B, that was b. Now, the thing is, the limitation basically is that when t becomes large, obviously we can see when this value would become very large, this value would also become very large, right? So for value of t such as infinite or infinity, whatever you call it, the model will no longer be valid because for t equals infinity, b would also be equal to infinity. So we would not be able to find out a proper value. So this is the limitation of the solution, right? Is this clear? And this is not given. Like one might say that t is infinity. So it is obviously true that the size would increase. But this is the limitation. We would not be able to find out the exact size. Okay. We would not be able to tell precisely that this would be the size. So this is how
Why?
we.
I didn't understand.
Sorry.
I didn't really understand this
Okay,
part of the question.
I'll explain this. Okay, no worries. Okay, look. Okay. For my okay, first I would like to ask you that what do you understand by this equation? What do you understand by this equation? That for different values of t, we will have different sizes, right?
Yes.
Okay. Now, you know, in such questions, you basically have to look at your solution and think about different t's, and then imagine that which t would basically, make a problem for us. For example, if we say that t is going on continuously, so there would be a time when t is infinity, right?
Yes.
In that case, this whole factor would also become infinity, e to the infinity would be infinity, right? And this b would be infinity as well. Now, in this case, we do not have any defined value, any certain value. So, this model or this differential or this solution is basically does is not defined for such big t's. Okay, so this is what they asked us: describe any limitations of this solution. And this is the problem: when t becomes large, the size of culture will become very large, and the model will no longer be valid, right? Like, we would not be able to find out a certain value of b, right?
Yeah, I got it.
Okay, all right. So let's talk. Okay, all right, so we are done with this. Okay, all right, Ranjani. So, are you clear with the basic idea of differential equations? How to create it? You don't know how to solve it. You don't know how we got this. But if you have been given with the solution, you know that how you can prove it, right? By basically taking derivative with respect to time on both sides. And after substitution and all that, you will end up getting the differential equation which we initially had. And what was the difference in general and particular solution? In general solution, we have constants, and in particular solution, we find the value of those constants, right?
Yes.
Okay. And in the last part, whenever you have been asked to find out the limitation of any solution, first we state the solution and we try understanding it, that okay, for different values of t, we will get the size of our in this case, size of our bacteria, right? So if t gets very, very big, such that t becomes equal to infinity, b would also become infinity. So this model or this solution was basically defined or designed to find the size at a particular time. But for such a time, we would fail in finding out the exact size. Okay, this is just telling us that it would be infinity and not a particular value. So this is why it is a limitation of this solution, right?
Yes.
Okay. Now let's just rub it and let's talk about how to solve a differential equation. Okay. So I'll write down a few types here and we'll see how to solve them. Okay. So the very first type is dy by dt equals minus 10 e to the minus 0.2t. And the second one is dy by dx equals 2 over x square plus 1. Okay. So do you remember the differential equation in last part? It was of this type: dB
Yes.
by dt equals kb. And in the second part of last question, you did not know how to solve it, but whatever way they solved it, they just uh, gave us the solution, and the solution was b equals something. Okay, so how do we get this? Whatever the solution would be, in this case, it would be y equals something. In this case, again, it would be y equals something, right? So are you clear with this idea that whenever you
Yes.
solve a differential equation, this function comes here and it would be in this form? And how do we do that? We'll talk about that. Okay. We'll talk about the third type later. Okay. Now we know that whenever we have to find the solution, we will get this function equals something, right? Okay. So we have dy by dt equals this. Okay. How do we do it? We can take dt to that side. Dy equals minus 10 e to the minus 0.2 t with dt, right? Are you clear so far?
Yes.
And we can integrate this expression on both sides. On this side with respect to y and on this side with respect to t. Now what do we get here? We have this one dy equals integration of 10 e to the minus 0.2 t dt. Aren't we going to get y for this expression? Because we have 1. When we integrate 1 with respect to y, we get y, right?
Yes.
Okay, so left side is clear. Let's talk about the right hand side. So we have been integrating exponential functions so many times. How? Now this would be a good recap. We can take 10 out because it is a constant term. So minus 10 can be taken out and we have to integrate e to the 0.2 t dt. Okay. Now what is the derivative of this power? What is the derivative of this power? It is minus 0.2. And how do we integrate exponential functions? By dividing the derivative of the power. So minus 10 is outside the integral, it will come as it is. Now we write down the integral of this part, right? What will we have? E to the minus 0.2 t will come as it is, and this derivative of power will be divided. So are you clear so far?
Yes.
Okay. So minus and minus can be cancelled, and 10 divided by 0.2, I'll just write down the answer now. So we will get, what are we going to get? 50 e to the minus 0.2 t plus c. So this is what we get. And you could have said that when we integrate this side, we get y plus c, okay? But we don't write down the constant twice. We just write down the constant once. And when we are interested in finding the particular value, you will end up finding the correct value because you don't need two constants, right? We only write down constant on one side, that is on right side, and we assume that this constant is basically absorbed in this one. Okay,
Okay.
so what is the thing? The thing is that if you end up finding out such a differential equation, how do we solve it? End goal is to solve differential equation by basically taking this to the right hand side. We have this here and we had dy here. Now we have to integrate both sides. Okay, this side would be integrated with respect to y and this with respect to t. So for this we get y, and for this obviously it would be different for every question, so we have to integrate it accordingly, and the c would come once at the end, right? Are you clear with this?
Yes.
Okay, very good. Right, let's do the second question. Okay, now we have to integrate the, now we have to solve this differential equation. In order to solve any differential equation, you have to integrate it. Okay, how do we do it? We'll take this dx to that side. Dy equals to x square plus 1 dx. Now we integrate both sides. Dy equals, and we have to integrate this side. Okay, this becomes y, and for this side we'll take 2 out, just so we have 1 over x square plus 1 dx. And Ranjani, how do we integrate this expression? You know that we have x square plus a square thing in the denominator, so we use
The tan.
Very good, very good, very well. So we will get y equals to it's tan inverse. Tan inverse x plus c, right? Do you agree?
Yes.
Okay. So is everything clear so far? Are you finding it good or difficult or okay?
Yes, it's fine.
Okay.
It's okay.
Okay. Right. And then we have third type. Now this is a bit different, but don't worry, we will be doing it in a similar way. What if your differential equation is of this type? Dx by dt equals 1 by x square. Now, if you try doing it in similar way, if you take t to that side, what will you get? Dx equals 1 by 6x square dt. Now this is problem. This is not right. Why is it problem? Because x is here, dx is on this side and x content is on this side, and we cannot integrate this function with respect to t because we don't have t, we have x. Okay, so here we can see that things are a bit problematic. So no worries, we just have to make a small change and everything will get same again. Okay, and what is the change? This is the change. I can write this differential equation by taking reciprocal of both left and right hand side. How? Reciprocal of left hand side would be dt by dx equals 6x square, and of right side would be 6x square, right?
Yes.
Okay. And now if I take this dx to that side, things are good again. This would be 6x square dx. And again, we have to integrate it on both sides. This will give us t equals 6x to the 3 divided by 3. And this would become t equals 2x cube. Do you agree? Plus c, right? But the thing is, in the very beginning, I told you that whenever you have been asked to solve a differential equation, if it is this type of differential equation, you will get x equals something. Okay, this function equals something. When we had this, we got y equals something, and again when we had this, we got y equals something. So initially in this question, we have dx by dt. So the solution should be in this form. If we have in this form, we can easily make x the subject. How? By making it the subject, we can take c to that side, t minus c by 2 cube root equals x, right? And now we have our solution. So have you understood this example, the third one?
Can you please repeat the third one
Yes,
again?
yes, definitely. Okay. So I'll just rub. Are you clear with one and two?
Yes.
Okay. So let's just rub it and then I'll tell you. Okay. So what if your differential equation is of this type? What have we been doing? We have been taking this side to that side and then integrating. Okay. Let's try doing it this way again. Dx equals 1 by 6x square dt. Now, don't you think that there's some problem? Like you can't integrate x with respect to t, right? So, in all the previous examples, like in this one, we had t here. So, when we were taking dt to that side, things were clear. We were automatically able to integrate it with respect to t. But this time we have t here and x here. Although it should have been in this way. It should have been with dx, right? This expression should have been with
Yes.
dx and not with dt. This is your alarm. This is how you will be notified that how to conduct such questions. Okay, simply let's rub the wrong solution. You will take reciprocal of both left side and right side. Reciprocal of left side would be dt by dx. And what is the reciprocal of right side of this side?
6x squared.
Very good. Okay. And now when I take this to that side, things again are good enough. We have dt, and now 6x square is with dx. Now I am in the form of integrating it and doing it whatever we were doing things. Okay. So this would give me t. And how do we integrate 6x square? 6x, we have square, so 2 plus 1 would be 3, and we have to
3.
divide it by new power. So this is 2. So we have 2x cube plus c. T equals 2x cube plus c. But the thing is that whenever you solve a differential equation like this one, it should have been x equals something, okay? Just like here, we had y in the numerator, so we have y equals something. So in this case, we should have x equals something, but we are having t equals something. So we need to make x the subject of our equation, right? Why?
Yes.
Because this is how the solution is. So for making x the subject, we need to separate it. So we'll take c to this side. T minus c equals 2x cube. I can take this 2 to this side. So I will have t minus c by 2 equals x cube. And now I can take cube root on both sides just to get rid of this cube. And finally, I have an equation whose subject is x. And this is what my solution is. Okay, so have you understood this now?
Yes.
Are you sure?
Yes.
Okay, all right. So let's talk about an example. Example number 2. The number of fish in a lake is increasing annually. The population X fish in T years time is modeled by the equation. Now they have told you the differential equation. dx by dt equals 0.2x. This year, there are 300 fish. So part A is work out a formula for the number of fish after t years. Okay. Now I want you to help. Sorry. Now I want you to help me in this question. Okay. Let's just understand the question first. The number of fish in a lake is increasing annually. Now, this could have been extremely important information for us if we were asked to make the differential equation. Here they have given us the differential equation. Okay. So, after full stop, we have the population X fish in T years time is modeled by the equation this year there are 300 fish. Work out a formula for the number of fish after T years. Now, what do you understand by part A? Like, what do you think they want you to do?
Um, so currently there are 300 fish. So we have to find out how many, the number of fish there are after 5 years. I mean, after
T
3 years.
years.
We have to frame an equation.
Yes. So basically, you have to make an equation using this. Okay. Using this. So, how do you do that? Okay. Let's talk about the solution. Here, Anjali, in differential equation, the questions would be very simple. Either they will ask you to make the differential equation or they will ask you to find the solution. But obviously, the statement would not be that straightforward. Now, here, this statement is not asking you to solve the differential equation. In fact, the statement is work out a formula for the number of fish after T years. Now, what do we understand? That on this hand side, we will have the number of fish, and on this hand side, we will have an expression with T. So every time when we put value of T, we get number of fish in that year, right?
Yes.
Okay. Now let's just do it. Okay. So we know that we have to solve the differential equation, right? Do you understand this? That what we have to do? We have to solve this differential equation which they have given us. Okay. Now, how do I do it? Do I take this dt to that side and integrate, or I take the reciprocal first? How will I integrate this?
Reciprocal first.
Very good. Because if I take dt, dx and this x would be not together, right? So step one is to take the reciprocal. So dt by dx is 1 by 0.2x, right? This is what the reciprocal is. And now I can take x to that side. So I will have dt equals 1 by zero point 0.2x dx. Okay. Now, what is the next step, Ranjani? How do I solve a differential equation? What do I do now? I have to,
Or you have to
yes,
integrate it.
very good. Integrated, okay. So for this side, we will get t. And for this side, what will we get for this side? So we have x in the denominator and the derivative of x is in the numerator, right? You can always write this as 1 by zero point 0.2. You can take it out and you have 1 by x dx, okay. Now, what do you see? In the denominator, you have a
X.
function whose derivative, what are you saying?
Ln x.
Very good, very well done. So we have t, 1 by 0 0.2 is basically 5, and the integral is ln x plus c, right? So is it clear?
Wait, why 5?
1
Isn't it
by
1 by
1 by
2?
0 0.2. 1 by 0 0.2 is basically 5.
Oh, yes, yes, it's 1 by 0.2, not
Yeah,
2.
okay.
Yeah.
So very good. So should we stop here? Are we done? Are we done? Or should we do something else?
Um, we can do one more question.
Yes. Say it again.
We can do one more question and
Yes,
then
yeah, we will. No, we will do one more question, but like, no, my question is that should we stop here? I mean, like, are we done with the first part?
okay. Um and then next, no, yes, we are done.
Look, we had x in the numerator now. So what does this mean? Our expression should be x equals something, right? And not t
Yes,
equals something. So we have to make x the subject, right? We have to
yes,
make x the subject
yes.
of this equation. So t minus c divided by 5 would become ln x, right? I have taken this c to this side and I've taken this 5 in the denominator. And I need to get rid of this ln. So how do I get rid of this ln? By taking what?
E,
E on both
exponential E.
sides. Exponent. Very
Yeah.
good. So this would be e to the t minus c by 5 equals, this would become x, right?
Yes.
Okay, so we are done. But obviously, we have been given this as well. So prefer finding out the constant as well, okay? Because they have clearly said work out a formula for the number of fish after t years. That if t is 5, you insert 5 and you get number of fish. So right now we have c as well. We need to find out its value using this. So this year there are 300 fish. We need at least two values, okay? This is x, and what would be t? What would be t? This year
We have to
means,
just substitute 300 into the equation.
yes, and what else? Okay, if we substitute 300 only, we will not be able to find the value of x. We need
We
to
need a
insert
C.
t as well. We have to find c, okay? We have to find c. We have to find c, not t. The expression at the end would have t because this is what we have, right?
C use.
So
Yes. Okay.
how do we like what value of t are we going to use? We have x equals e to the t minus c by 5, and our goal is to find this value of c. So we have been told that this year there are 300 fish. So we will take it this way at t equals 0 because we are starting this year. Okay, we are starting this year. So t is 0 and number of fish is 300. Now we use t0 and x equals 300 to find the value of c. Right? Have you understood this
Yes.
or not?
Yes.
Okay.
We're taking T as 0 because it said that initially there are 300 fish.
Yeah,
Fish.
like obviously initially has not been written, but this year means that t is 0. And another thing is that, in such questions, whenever they have not mentioned t, it would be a bit straightforward that you will be using this. I mean, not in every question, but this time around, since we are making this formula and everything this year for t years, okay? So this year means that t would be 0. This is our starting point, right? This is the initial value. So
Yes.
300 equals e to the minus c by 5. Okay, and how do we solve it? How do we find the value of c? By taking natural log.
Yes.
So ln of 300 equals ln of this would give us minus c by 5. And so we will have ln 300, this whole thing multiplied by 5 equals minus c, right?
Yes.
And this is going to give us c equals, ln 300 by 5. Actually, my calculator is lost. Can you do it for me, please? ln 300 by 5.
Yes. 7300 by 5. 1 second. 1.14.
Okay. So we have 1.14 minus 1.14, right? Okay. So once we have our C, we can just insert in this, and the expression would become x equals e to the t plus 1.4 by 5. Now this basically is a formula for the number of fish after t years.
Yes.
Okay. All right. Okay. So anything which you would like to ask?
So C equals minus 1.4. So, oh, that's the complete formula. I got it.
Yes, 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 yes.
So,
This is the particular solution, you can say.
hmm,
This was the general one, and this is the particular one, right? When we uh, do it for a particular value of C, we get this. And if you look at your book, you might find it different, but it is because they have done and written it in a different format. Okay, the actual answer would be same. This is equivalent to the solution which your book has, but their solution is a bit different because they have solved it for E and they have done it that way. Like they have done it this way: e to the t by 5 and e to the 1.4 by 5 in this way. So it is same, right? Don't worry about that. So this would be your solution. Okay, so are you clear with this question?
yes.
Okay. Now again, the second part was describe any limitations in this solution. So what do you think? The answer is a bit similar.
That after a certain amount of
Yes,
years, there won't be, the number of fish won't
exactly.
be.
Exactly.
Oh, okay. But I
All right.
still don't get why is that? Like,
Yes, what? Why is what?
why is why after a certain amount of time the number of fish will cannot be calculated?
Okay. All right, I'll tell you. Okay, in the previous example, because we had bacteria size and t equals infinity, like the fact that bacteria cannot become infinite in its size. Do you get it? Like we had, what
Yes.
did we have? We had b equals, just let me write down that again. We had b equals a e to the kt. Now when t is becoming infinite, this is basically telling us that b is also becoming infinite, right? But that is not possible. Our bacteria cannot become infinite because of restrictions, because of some resource problem, and because of all that. So this basically is telling us that for t equals infinite, the value calculated would be incorrect. Similarly, in this part, when t becomes infinite, think about this. Okay, you will not be able to understand this way, but think about this example this way. If you have time equals infinite, do you think that you will have infinite many fishes? No, because you have some restrictions, you have some water and food restrictions, right? This means that for t equals infinity, x would be infinity. But number one, infinity is not a value. Number two, yes, x will grow, x will become more, but not infinite. Like that is not possible. Okay, it is not possible that fish keeps on going with time, keeps on growing with time. That is not possible, right? This basically,
Yes.
the fact that t equals infinity is giving us x equals infinity, which is not possible, because like we have been dealing with so many things so far that we know that this is now how life works and this is now not how things work, right?
Yes.
Okay. So, and obviously, here they were talking about a lake. So, can you have like infinite many fishes in a lake? No, you cannot. But t equals infinity is telling you that number of fishes would be infinite. That is not possible, okay? You cannot have infinite fishes in one lake, no matter how big it is. So, this is certain
Hmm.
that for t equals infinity, x equals infinity cannot be the answer. So, this is why this solution is limited for t equals infinity, right? So are you clear with this?
Yes.
All right, okay. So any questions, anything which you would like to ask?
No, ma'am, it's fine.
All right, so I'll stop the recording.